In this video you will learn what is an inductive proximity sensor and how it works. Proximity sensors is a non-contact sensor that provides input data to a PLCs when it detects the presence of an object. Inductive proximity switches are used to detect metal objects contactless, and they are offered in variety of sizes with threaded barrels to flat surfaces. Inductive sensors are built with a ferrite core and a coil of thin wire around it connected to an oscillating circuit. When energized, the face of the sensor generates an electromagnetic field around the face of the sensor. When a large enough metallic object enters the field created by the current flowing through the coil, the oscillator is stalled and a discrete signal is generated, signaling the presence of an object. The type of metal being detected strongly influences the range of an inductive proximity sensor. Metals such as steel containing iron make the best target, while aluminum reduces the sensing range by about 60%. Discrete proximity sensors behave as a momentary switch. So, what is a momentary switch? Imagine a doorbell that is activated every time it is pressed. This means that it will only change its state when actively triggered. When the doorbell is unpressed, the doorbell is deactivated. Going back to our example, the inductive sensor will remain off when there is no metal in front of it. When the metal enters the sensing range, the sensor will turn on, and it will remain on as long as the metal is in the operating area. Once the object that triggers the switch leaves the operating area, the switch will return to its normal state. Inductive sensors are classified as PNP or NPN output. And they are classified as flush or unflush mount, also known as shielded or unshielded. Let's compare both types. In a PNP transistor, current flows out of the base P to turn the transistor on. In an NPN transistor, current flows in the base P to turn the transistor on. PNP transistors are called sourcing, as they source current once the switch is closed. NPN transistors are called sinking, as they sink the current once the switch is closed. PNP output sensors are commonly used in North America and Europe, whereas NPN output sensors are commonly used in Asian countries. Proximity inductive sensors can be either flush or unflush. By looking at both versions, the first thing we notice is that the unflush sensor has a kind of a hat sticking out of the face of the sensor. Flush or shielded proxies have a metal housing all the way up to the sensing face of the switch. This reduces the range of the sensor, but it allows the sensor to be mounted flush with a metal surface without detecting the metal around it. Unflush or unshielded proxies have a longer range since the face of the sensor sticks out. This allows the electromagnetic field to extend out from the sides of the sensor but makes it more susceptible to damages such as impact at the face of the sensors or false triggering in case there is metal around it. For this reason, shielded sensors can be mounted flush to the metal surface. An unshielded sensor should be mounted away from a metal surface to avoid false triggering in case there is metal around it. So, now let's go over a quick review of what we have learned about inductive proxy sensors. Inductive proximity sensors have a long functional life and high reliability due to the lack of physical contact between the sensor and the object detected. Inductive sensors are used to detect metal. Every metal affects the sensing range differently. Inductive sensors can be either PNP or NPN output. And they can be either flush mount, also known as shielded. Or they can be unflush mount, also known as unshielded. Please subscribe to our channel and click the like button if you find this content valuable. Thank you, and I will see you in our next video.